Well, greetings, everybody. So what you see here is a problem from our assignment about hypothesis testing. And I thought it'd be a good idea based on a question I got to go through each part of this. And in the process of doing that, explain the whole procedure for hypothesis testing. Okay? So if you can read it up here, somebody makes a claim about what the mean salary for a population of managers is. Okay? And then we're given some data regarding a sample to evaluate that claim. So we have a claim about what the mean salary for a population is, and then some data from a sample. Okay. Now, I'll let you read this in order to get a feel for what we're given, but I'm going to summarize it on my whiteboard as I go through it. Okay, so first of all, whenever I read that problem, I read the claim that some politician claims that the mean salary for managers is more than $84,000. So that claim was stated in the problem. As far as how that would fit into being our null or alternate hypothesis, that would be our alternate hypothesis. Okay? The mean salary is more than 84,000. Okay? So under my alternate hypothesis, I'll say the population mean is more than $84,000. Why is that? Well, because the null hypothesis always involves equality somehow, and the alternate doesn't. So if this was the claim that was made, and it's either the null or alternate, because this claim doesn't involve an equals or a greater than or equal or less than or equal, it's the alternate. Okay? And then the null hypothesis is whatever is true if the alternate isn't true. So it's like this. Either the mean is more than $84,000, which is the alternate, or the mean is $84,000, or the mean is less than $84,000. So that makes the null hypothesis less than or equal to $84,000. Okay, so that's our first task when we do hypothesis testing is we'll read the problem, we'll see what kind of claim is being made about the population mean, and then from there we have to figure out, based on that, what the null and alternate hypotheses are. Next thing we do is we need some kind of a sample, okay? And about that sample specifically, we need to know the sample size and the sample mean. So in this particular question, I notice like I'm given a data set. So from that data set, I'll need to open it in StatCrunch, and I'll need to calculate the sample size and the sample mean. Okay, so you can do that like this. You can go to calculators summary stats and columns, and you can select the mean and the sample size, and you can calculate that. That's something that I've highlighted in a lot of the other videos that I've made. Okay, how to use StatCrunch. If I do that for this particular sample in StatCrunch, then what I'll get is that the sample size is 30. Okay. And the sample mean from StatCrunch again is $84,034.67. So there I have it to 3 decimal places. Okay, that's our next step, is whether I use StatCrunch to figure the sample size and the sample mean out, or whether it's just given to me in the question, I need to know it. All right. The third thing I do is calculate the standardized test statistic. That is x bar, which is the sample mean, minus mu, which is the population mean. We'll get that from the null hypothesis. Okay? See, null hypothesis for population mean. Divided by the population standard deviation, and that will be given somewhere in the problem, divided by root of sample size. So there's my sample mean, population mean. If I read that question, it will give me that the population standard deviation is 8,000. Okay, so there's that. And then sample size is 30. So I calculate all this. There is my standardized test statistic. Okay, now that's actually one of the answers along the way here. I identified the standardized test statistic, rounding it to 2 decimal places. If I round that number that I got over here to 2 decimal places, well, then I'll get 0.02. Okay, but there's the number I calculated from what you see on my whiteboard to several more decimal places. Okay, next thing, we'll find the p-value. So how you find the p-value, well, let's say this. You will use the standard normal every time when you find the p-value, okay? But how you do that depends on different cases, okay? It'll depend on if the null hypothesis says that the population mean is less than or equal to a number, or if it says greater than or equal to a number, or if it says equals a number. There's all these different cases. We'll have to figure out which case we're in, and then we'll find the p-value that way, okay? So it's going to be an area either right or left of the standardized test statistic, okay? Now, which of these cases are we in? Does our null hypothesis say the population mean is equal to a number? It doesn't, does it? What did it say? It says the population mean is less than or equal to 84,000. So it's not this last case, and it's not the one before that. It's neither of these. And it's not this one either. It says the population mean is less than or equal to 84,000. It's that first one. Okay? All right. So we just have to look at our null hypothesis in each of these cases. There's 4 cases, okay, to decide how to calculate the p-value. Now, as we're in the first case, on the standard normal curve, the p-value is the area to the right of the standardized test statistic. Okay, so let's see how to do that. Now I'll use StatCrunch to do this. Okay, so I open under the normal calculator the standard normal with a mean of 0 and a standard deviation of 1. And what did it say? It says I need to find the area that is to the right of the standardized test statistic, which was 0.023735. Okay? All right, so let's do that. So I set this to greater than to find the area to the right of the standardized test statistic, which is 0.023735. Okay? And then that, like whatever I get from this, that's the p-value. Okay, so there it is, 0.4905, 0.491 if you went to 3 decimal places. This is the area to the right of the standardized test statistic. That's what I needed. Okay, that's what the p-value is in our particular case. All right. Okay, so yeah, in our case, p-value is the area right of that STS standardized test statistic, 0.4905. All right. Okay, so look at what we might put in for that. Here it says that the right answer is 0.492, but depending on how you round some of the numbers leading up to this point, you can get something close to 492 or 491. If I were to round my answer to 3 decimal places, I would get 0.491, which is given as one of the correct answers. Okay, now, what's our conclusion? That's the next part of the problem. So you might say, do you reject the null hypothesis? Do you fail to reject it? All of these under that last part of the question are making a conclusion from our test. So, well, here's how you make that conclusion. If the p-value, which we calculated here, is less than or equal to alpha, so that's like the threshold for the test, right? They'll be given somewhere. Like, so here it says alpha is 0.07. Okay. All right. So if the p-value is less than that, we'll reject the null hypothesis. If it's more than that, we'll fail to reject it. So in our case, the p-value, what was that? 0.4905. Alpha is 0.07. The p-value is definitely bigger than alpha. So according to this, we won't reject the null hypothesis. We'll fail to reject it. And since either the null hypothesis is true or the alternate is true, if we fail to reject the null hypothesis, then that means that the evidence doesn't support the alternate. Okay? All right, because one of these or the other has to be true. If we're not throwing out the null, that means we can't go about accepting the alternate. All right, so where is that in here? Well, that would be this one. They're going to fail to reject the null hypothesis. And there's not evidence to support the claim made as the alternate. Right there, that is the claim made as the alternate hypothesis. Okay? All right, so there we go. Now that's the whole procedure. So there's a lot of math in this procedure. And it's so easy, I guess, to go through this and lose sight of what you're actually doing and what it means. So I thought it wouldn't be bad to go through a summary of what happens here. So basically what we're doing here is we're investigating the claim or the possibility that the average salary for a population of managers is less than or equal to 84,000. Okay? So that claim's being made. Maybe it's true, maybe it's not. But that's out there as the claim. So we collect a sample. And we find among that sample the mean salary is about $84,034.67. Now think about it like this. If this original claim was true, and if this mean from our sample was big enough, if it was a lot higher than 84,000, then that would seem suspicious. So I don't think this number is actually high enough to make that claim suspicious, but let's say that the mean salary for population managers was less than or equal to 84,000. And then I took a sample from that group and I found, well, in the sample, I found the mean to be, $1.5 million. That would seem very odd. You'd think if that is actually true about what the mean salary is, I don't see how you get a sample with a mean as big as $1.5 million. But the issue is we calculate the sample mean. And if that is big enough, as far away from that is what I mean, then it starts to look suspicious. And you think maybe this original claim isn't true after all. Okay? So yeah, if we had a sample mean that was a lot higher than $84,000, then we would start to question whether that was actually the truth. Okay? So it comes down to this. All right, for this particular question with these numbers. If the mean salary for the population is actually less than or equal to $84,000, then our sample mean of $84,034 is so unlikely to question the claim is true. Is it that much bigger than 84,000 to make that seem suspicious? It's a little hard to say looking at it. We need to calculate actual probabilities to tell. All right. So the math that we've done does this. Here's what it accomplishes. We assume that, all right, fine. Suppose that the population mean is less than or equal to $84,000. What we've actually calculated is that the probability of finding that sample, as we did with a mean of $84,034, is about 49%. That's the p-value. The odds of what actually happening is like 49%. Okay? Now, is 49%, is that unlikely enough to make that original claim suspicious? Well, here's another aspect of the problem. When I'm given alpha as 0.7, that means 7%. We'll say, all right, if the odds of our sample being what it is less than 7%, then we'll throw out that original claim. We'll reject it. Okay? But that's not true this time. Our sample has a probability of existing of like 49%, and that's not less than 7%. In order to doubt that original claim, this number in our sample would have to occur with less than a 7% chance. Then we would doubt the whole premise of the question. We would doubt that original claim. Okay? All right, so that's what's happening in, I guess, a more explanatory detail. Here's what it means if you want to think. But over here, this is the procedure. All right, now I wanted to offer both those to you. I understand that you might not care at all about what does it all mean and all these numbers we find, what do they do? How do they fit together towards that very end result of failing to reject the null hypothesis? How do we get there? Well, okay, so that's over here in case you're interested.